So topic 11, which is about air and water, and the subtopic is about nitrogen and the fertilizers. So first thing is the manufacture of ammonia by a Haber's process. How we can manufacture ammonia? Ammonia is NH3 by using this Haber's process. So the manufacture of ammonia is by Haber process a reversible reaction when we have nitrogen molecule reacted with hydrogen. As a result, when they combine, it will give 2NH3. And the energy change or enthalpy change for this reaction is negative. It means the forward reaction is exothermic. So when the reactant form a product, the reactants have high energy and the product is having low energy. So nitrogen and hydrogen have high energy where ammonia is having a low energy. So N2 plus 3H2 gives 2NH3. Now, how to obtain this for manufacture of ammonia by Haber process? The reaction is reversible. So, how to obtain these two reactants? Nitrogen is there, we obtain from air, and hydrogen is there, we can obtain by hydrocarbons, compound which contain carbon and hydrogen, or we can also use electrolysis, but that will increase the cost if we use electrolysis. So, nitrogen combined with hydrogen, as a result, it form ammonia, where the forward reaction is exothermic, release heat energy. So if we want to obtain nitrogen, we can obtain nitrogen from air. It comes from the air by fractional distillation. And for hydrogen, there are several ways. Some of them are listed, like if methane react with steam, it gives carbon dioxide and hydrogen. So we can have this hydrogen, or it can also be made by cracking. What is the meaning of cracking? Cracking means breaking down of the large molecule into small molecules. We call cracking. So we have C2H6. If we crack or break down, it will become C2H4 and H2. So breaking down of the molecule or hydrocarbon or cracking of a hydrocarbon also produce hydrogen. So we can use this hydrogen for manufacture of ammonia. So first what we do, we have a hydrogen gas which is H2 and we have nitrogen gas which is N2. We pump them. So the nitrogen and the hydrogen gases are pumped and they are compressed. Then we use a catalyst here. The catalyst which we use for this reaction is iron. So when nitrogen and hydrogen they are pumped into this chamber, they move over the catalyst. And what are the conditions? The reaction condition, you have to learn these reaction conditions. The reaction condition is 200 atm, the pressure which we apply, and the temperature is around 450 degree centigrade. Why this very high temperature? Because the inert nature of the nitrogen does not tend to react below this temperature. Around 400 its reaction started. So nitrogen can react at high temperature due to its inert nature. So that's why the temperature is high. And why the pressure is high? Because you can see we have one molecule of nitrogen and three moles or molecule of hydrogen. So total 4 moles of reactant and 2 moles of the product. So when we increase the pressure, the balance or equilibrium will shift towards the right hand side. So increase in pressure, shift the balance or equilibrium towards the right hand side. That's why we prefer a high pressure. So what happened when we mix this nitrogen and hydrogen? So the nitrogen and hydrogen combine, they mix here and passes over the catalyst. So as a result, when they combine, so it's because the reaction is reversible. So some of the nitrogen and hydrogen which form ammonia might decompose, and if it is decomposed, it will return back. But what happened if the nitrogen and hydrogen, when they react and it turn out to be ammonia, so that ammonia, when it enter the cooler, we cool down, we remove the energy, So we'll get this NH3 here. So reaction is reversible. Once nitrogen and hydrogen react, they will form ammonia and we cool down and take out the ammonia from the bottom. The one which does not react, we again pump them into a chamber and they continue to move until they are also converted, the other molecules are also converted into nitrogen and hydrogen. Form ammonia, like the two elements react and form ammonia again. So this is how we manufacture ammonia by a Haber's process. Reaction condition. The reaction conditions are very important. You have to memorize the reaction condition that you need a 200 atm around 450 degrees centigrade, and we use iron as a catalyst. Then, as we know, the reaction is reversible. What will be the effect of increasing a temperature, and what will be the effect of increasing a pressure or decreasing a pressure? So when nitrogen is reacting with hydrogen, like N2 is there, which is nitrogen, and that reacted with hydrogen. So N2 plus 3H2 will give 2NH3. And the forward reaction is exo. So what will be the effect of temperature if the reaction is reversible and we change the temperature? We can, two things can happen. We can increase the temperature, we can decrease. If the reaction is exothermic, reactants have more energy and the product particles will have less energy. So what we do, if we increase the temperature, like we have 450, this reaction occur around 450. But what if the temperature is more than 450 or less than 450? So the reaction occur at 450. But if we reduce the temperature, if we decrease the temperature, and we increase the temperature, so if we decrease the temperature, two things will happen. Number one, what about the balance? Because it's a reversible reaction. So for reversible reaction, if we decrease the temperature, where the balance will shift for decreasing temperature, because we remove the energy, so equilibrium or the balance will shift toward the right hand side, the decrease in temperature. So if the balance shifted towards the right hand side, so we can say the equilibrium or the balance, that is shifted right. If the equilibrium or the balance is shifted towards the right hand side, what will happen? The yield or the amount of ammonia will increase. We'll get more ammonia. But what will be the result of the rate? Because the temperature and rate are directly proportional, so rate of the reaction will decrease or reaction will slow down. And if we increase the temperature, if we supply energy, we increase the temperature, so the product will absorb energy and they will start to form back the reactant. So increasing a temperature, what will happen? Where the balance will shift, the equilibrium or the balance will shift towards the right hand, towards the left hand side. And as the equilibrium shifted left hand side, what will happen to yield or amount of ammonia? That will decrease, like we'll get less ammonia. And what happened to rate? Rate and temperature are directly proportional, so rate of the reaction will increase. So this will be the effect of changing the temperature more than 450 or less than 4. If it is less than 450, you will get more ammonia, but the reaction will be very slow. If the temperature is more than 450, the reaction will be faster, but the amount of the ammonia which we will get at the last will be smaller. So that's why we prefer like around 450 is a good temperature for this to have a better yield as well as the optimum rate. And same thing, if we have a reversible reaction and we have gases involved in the reaction, so there is the effect of the pressure. So we are using 200 atm, but what will happen if we increase the pressure or we decrease the pressure? So if we increase the pressure, like if we increase more than 250, what will happen? Equilibrium, when we increase the pressure, it is always shifted towards the side of less moles. So reactant side we have 4 moles and the product side we have 2 moles. So when we increase the pressure, the balance or equilibrium will shift towards the right hand side. So if it equilibrium or the balance shifted towards the right hand side, so if the balance or equilibrium shifted towards the right hand side, we will get more ammonia. And if we get more ammonia, and because the pressure and rate are directly proportional, rate will also increase. But what is the problem with this? If we increase the pressure, it increases the cost as well, because to create high pressure, we need more energy. So more energy is needed, and as a result, if more energy is needed, what will happen? It increases the cost. Like you need a greater amount of fuel to create enough pressure so that the reaction can occur. And the second thing, decrease in pressure. So if we decrease the pressure, where the equilibrium will shift, it will shift towards the side where less moles or less particles. So 2 particles of the product, 4 particles of the reactant. So it will, the equilibrium or the balance shifted towards will have less ammonia, and the rate will also decrease, so it won't be accurate. So this is how the reversible reactions are affected by pressure. Is it clear that how the yield and the rates are affected by changing the temperature and changing the pressure for reversible reaction for manufacture of ammonia by the Haber's process? Then what are fertilizers? Fertilizers are the compound which provide essential nutrients to the plants. And what are the essential nutrients? So those compounds which can provide nitrogen, phosphorus and potassium, NPK. Any compound which can provide nitrogen, phosphorus and potassium, and it is water soluble, like it can dissolve in water, because the plants cannot absorb the solid, it should be in aqueous or solution form. So those essential nutrients which can provide those compounds which can provide these essential nutrients such as nitrogen, phosphorus and potassium, we call them as fertilizers. So and what is the use of these elements for the plant? Nitrogen is needed for the growth of the plant. Like if we want the plant to grow better, so for growth of the plant we need nitrogen. Phosphorus mainly is there for the root and the stem, and potassium is there for the fruit or the flower. So better fruit or the better flower production, we need potassium. So basically for a better growth of the plant, we need all these three nutrients such as nitrogen, phosphorus and potassium, and we call them as NPK. But it is not necessary that one compound can provide all these three elements. Like example, if I say I have ammonium nitrate, so which essential compound, the nutrient it can provide? It contains nitrogen, hydrogen, oxygen. But which one is the essential for the growth of the plant it can provide? So it can only provide nitrogen. If we have potassium nitrate, KNO3, So what is the essential nutrient it can provide? It can provide nitrogen to the plant, and this can provide potassium. And if we have ammonium phosphate, so what are the essential nutrients this can provide? It can provide nitrogen, it can provide phosphorus. So these all are refers to fertilizer. Why? Because why I call this is a fertilizer? Because it is providing nitrogen. Why I call this is a fertilizer? Because it is providing potassium and nitrogen. Why I can call this as a fertilizer? Because it can provide nitrogen and phosphorus. But what if I have a compound like calcium chloride? So calcium chloride, is it a fertilizer? No. Why it is not a fertilizer? Because it does not provide nitrogen, it does not provide potassium, and it does not provide phosphorus. So those compounds which can provide essential nutrients to the plant, such as nitrogen, phosphorus, and potassium, are refers to fertilizer. And the type of the fertilizer which we use depends on what is the need, like what is the what for what purpose we need a fertilizer. If we want a better growth of the plant, we prefer to have a nitrogen fertilizers. If we want a better root system, then we prefer to have phosphorus fertilizer. If we want to enhance the growth of the fruit or the flower, we prefer potassium fertilizers. So fertilizers are the compound of nitrogen, phosphorus, potassium, which can improve the agriculture or agricultural productivity. Then the carbon dioxide and a methane. So state the carbon dioxide and methane as a greenhouse gases. So basically, what are the greenhouse gases? The gases which trap the radiation from the sun and cause the average temperature of the earth to rise. We call them as a greenhouse gases. Major contributor, water is also a greenhouse, but the major contributor is carbon dioxide and methane, because they tend to change the climate. Then this is about the carbon cycle, like how carbon dioxide can be formed or removed from the environment. So example, we have the carbon dioxide in the atmosphere. So there is CO2, carbon dioxide is there in the atmosphere. The green plant absorb the carbon dioxide by process of photosynthesis, and they will store this as a carbon compound. But if at night, what happens when they start to respire, or if these plants start to decay or become dead, they release that carbon dioxide back again. What might happen? The plant might be eaten by the animal, and that animal respire, or when animal die, decay, it will release carbon dioxide. Then the plant might change into fossil, and fossil fuel, like that plant might be trapped in under high pressure and limited supply of oxygen, so it turn into fossil. And when we burn fossil, that what happens, that fossil will also give out carbon dioxide. So this is like how the carbon dioxide percentage can be increased or decreased in the atmosphere. So if we have faster photosynthesis, the amount of carbon dioxide will decrease. Like if we have a greater rate of photosynthesis, the percentage of CO2 in the atmosphere will decrease. If we have like greater rate of respiration, the percentage of the carbon dioxide in the atmosphere will increase. So these processes can change the composition of carbon dioxide. So carbon dioxide can be formed uh, by the complete combustion, like about the carbon cycle. So CO2, the carbon dioxide is emitted by what? The process of respiration and combustion is emitting carbon dioxide, where carbon dioxide is absorbed by the plants, the green plants, turned into carbohydrate by the process of photosynthesis. And animals eat these plants, and the carbon consumed is released, or carbon component is released. And these animals or plants eventually die or decompose. Fed on these dead organisms, the carbon is returned to the atmosphere. Then how this carbon dioxide and methane are the greenhouse gases. What is the concept of a greenhouse gas? So greenhouse gases maintain the temperature of the earth high enough to support the life. So they are essential for us. If we don't have a greenhouse gases, then the temperature of the earth will be very low and we won't be able to survive. But the problem is the due to the human activities, the percentage of these greenhouse gases is continuously changing. Like this is our earth and the red part is representing the atmosphere. So when the radiations are coming from the sun, so when these radiation are coming from the sun like UV, ultraviolet radiation have a shorter wavelength, higher frequency. When it enter the earth atmosphere, so in our atmosphere we have greenhouse gases, we have water vapors, which is a greenhouse, we have carbon dioxide, we have methane, which is CH4. When these gases absorb this UV or a lower shorter wavelength, they re-radiate and they give out longer wavelength. But the longer wavelength cannot go out from the earth atmosphere. The shorter wavelength can go out from the earth atmosphere. So as a result, what happened? As it emit out a longer wavelength, so the energy is trapped within the earth atmosphere. So as this energy is trapped, if we are due to the human activity, like if we are burning lot of fossil fuel, so that cause an increase in percentage of the carbon dioxide. If percentage of the carbon dioxide increases, so more energy will be trapped within the earth atmosphere. As a result, what happened? The ice at the poles or ice caps, they start to melt. And when it start to melt, what will happen? As a result, the sea level will rise. So it is increasing, not only increasing a temperature, but it also cause the exponential change in the melting of polar ice. So greenhouse gases are useful to maintain the temperature. But what happened when the electromagnetic radiation at most wavelength from a sun passes through the earth atmosphere? So the earth absorbs some radiation and thus warm up. But some of the heat, how it is useful, because if it was not there, if carbon dioxide and methane were not there, then the earth will not absorb any infrared and any radiation. So this radiation which is coming from the sun will return back to the atmosphere. So the temperature of the earth atmosphere will be very low, like it will be very cold. Even in summer, like what we used to say summer, it won't be summer, it will be very low temperature, very cold. So because the amount of the carbon dioxide, water vapor and methane, they trap and release a longer wavelength, so they maintain a temperature of the atmosphere. So when the earth absorbs some radiation, it warm up. But due to as the atmosphere warms up, the greenhouse effect or the global warming, so yeah, one advantage is it support the life, like the temperature of the earth is maintained. But second thing, what is the problem is with that? Because we are continuously burning like petrol, diesel, crude oil, so it give out carbon dioxide. So there is lot of carbon dioxide now in the atmosphere. As a result of too much carbon dioxide in the atmosphere, what will happen? The temperature of the earth rise too much and that cause the melting of the ice, and due to the melting of the ice there will be a rise in sea level. So what are the disadvantages here? Advantage is just it maintain a temperature, but what is the disadvantage? It increases the average temperature, which we call a global warming. That is a major cause of a climate change. Like there are some places where it used to have rain, that climate has suddenly changed, it dries up. So there are several other potential effects which are related to the climate change. Number one, extinct of species, because some animals, some plant need certain condition to survive. So if these conditions will change, these plants or animals won't survive and they will become extinct. The rise in the sea level, because the polar ice caps are continuously melting, and that cause the level of the sea will rise, and then increasing a risk of skin cancer, because when lot of radiation enter the atmosphere, so it become dangerous and it can cause a skin cancer. So this is how methane and carbon dioxide contribute to a global warming. Is it clear? So the state, the formation of a carbon dioxide, how carbon dioxide gas can be given off. There are different ways carbon dioxide gas is given off. One is by combustion of carbon containing fuel. Like example, if we burn methane, this gives carbon dioxide and water. If we burn carbon, carbon react with oxygen, give carbon dioxide. So carbon react with oxygen. As a result, what it will give? It will give carbon dioxide. So this is one way. What about respiration? So respiration. So respiration is the glucose, like we have C6H12O6, that in the presence of oxygen, it gives carbon dioxide and water. So again, it will give out carbon dioxide. And thermal decomposition of carbonate, when we heat metal carbonate like calcium carbonate, on heating gives calcium oxide and carbon dioxide. If we heat magnesium carbonate, so magnesium carbonate on heating give magnesium oxide plus carbon dioxide. So these are the sources of the carbon dioxide, the ways by which carbon dioxide gas is released. And a reaction between acid and carbonate. So as we know, when acid react with carbonate, acid plus metal carbonate or metal carbonate plus acid, as a result, what it give? It will give salt, it will give water, and it will give carbon dioxide. So these are some sources of the carbon dioxide, how carbon dioxide gas is released. Then the sources of the methane. Methane means CH4. It's also a hydrocarbon which contain one carbon and four hydrogen. We call that as a methane. What are the sources of the methane? Methane is also a greenhouse gas. It can also cause a global warming. So how it is produced? It is produced or production or use of fossil fuel. Because when we are using fossil fuel, like the crude oil, that crude oil is also producing or giving out methane gas, CH4. Livestock farming, the animal waste, like example cattle farming, the waste of the animals, it is producing methane as well. So animal waste is also producing methane. So that the problem with that, because now there's a increase in demand for the meat, so as a result, what, or for a dairy product, so as a result, cattle farming is done at a large scale. So when cattle farming is done at a large scale, so means there will be more waste from the animals, and that waste is emitting out methane gas, which leads to global warming. And decomposition of vegetation, like when organic matter, organic waste, dead substances decay, that is also giving out methane gas. So these are the three main sources of the methane. One is by crude oil, fossil fuel, the second one is livestock farming, and the third one is decomposition of vegetations. And the methane is also a greenhouse gas.